You can bend a part to exactly 90 degrees, lift the ram, and watch it open up on its own. Nothing is wrong with the machine. By the end of this, you will know exactly what is pulling that angle open, which materials do it worst, and the three ways a fabricator beats it. Every bend is two things happening at once. Near the outside and inside surfaces, the metal is pushed past its yield strength, so it deforms permanently. But closer to the neutral axis, in the middle of the thickness, the metal never reaches yield. That inner band is only stretched elastically, and elastic strain is by definition recoverable. So when the punch lifts, that elastic band tries to straighten out again, and it drags the plastically bent material with it. The angle opens, and the inside radius gets slightly larger at the same time. That is springback. It is not a defect in the metal. It is the metal behaving exactly as elasticity says it must, which means you can predict who suffers. Springback scales with the ratio of yield strength to elastic modulus. A higher yield strength stores more elastic energy before it deforms permanently, so it recovers more. A higher modulus means the material resists that elastic strain in the first place, so it recovers less. That is why aluminium is the classic offender. Its elastic modulus is roughly a third that of steel, so for a given strength it springs back noticeably more. High strength and stainless grades also give you more spring back than plain mild steel, and every grade has a tolerance band on yield strength. So two coils with the same certificate can still come off the break at different angles. Geometry matters just as much. The bigger the inside radius relative to the thickness, the more of the section stays elastic and the more it springs back. Tight radii in thick material barely move. A large radius in thin sheet can open dramatically, and at extreme radius to thickness ratios, you are effectively just flexing the sheet. The forming method changes it too. Air bending only touches the sheet at 3 lines, the punch tip and the 2 die shoulders, so the material is free to recover and springback is at its largest. Bottoming presses the metal against the die faces and reduces it. Coining drives the punch nose into the material hard enough to yield it right through the thickness, which nearly eliminates springback, but it needs far more tonnage than air bending for the same part. So the first way to beat springback is the oldest: overbend. You aim past the angle you want by the amount you expect it to recover, so it relaxes into target. On a modern CNC brake, that is just a corrected angle in the program, held in a material and tooling specific table. The catch is that the correction is only valid for that exact combination of material, thickness, die opening, and punch radius. The second way is to stop guessing and measure. Angle measurement systems watch the actual bend angle during the stroke, work out the springback from how the material behaves under load, and correct the depth in real time. Some brakes do it by bending a small test amount, releasing and reading the recovery before completing the bend. Either way, the machine adapts to the coil in front of it rather than to a table written for a different batch. The third way is to design it out. Where the part allows, a tighter inside radius relative to the thickness reduces the elastic share of the section. Bending across the rolling direction rather than along it gives more consistent results in materials that behave differently in each direction. Stiffening features formed into the bend line, like a stitch or a coined relief, physically hold the angle. And on genuinely critical angles, plan a setting operation instead of hoping the first hit lands. Put it together and springback stops being mysterious. Higher yield, lower stiffness, larger radius, and looser forming all push the angle open, and every fix works by shrinking the elastic share or compensating for it. If your angles drift between jobs and nothing on the machine change, look at the material certificate before you look at the brake. Next time, what actually happens inside a fiber laser coil line running lights out for 24 hours?